Hello D3 My Way students, this is Ms. Doolittle and I wanted to record a short video about how to calculate rate of change. Another way that we often refer to rate of change is as slope. The words basically mean the same thing, okay? So I'm going to type this in here so you can see that it is the exact same thing as slope. All right, now this is meant to go along with the rate of change activity that is in Accelerate. So if you watch this video first, or if you've already submitted it and then you watch this video after the fact, my hope is, even though this is on a different topic, my hope is that it will help you. This particular graph is talking about speed, how speed changes over time. I think in the activity in Accelerate, it's talking about heart rate and then the amount of time exercising, but the method remains the same, okay? So I just found this graph that you're looking at right now is not in Accelerate. I found it out on the internet and just snagged a picture of it and thought I would talk to you about how we'll make some calculations with that. So here's the deal. What the question on your worksheet is going to ask you is, what is the amount of time during which this component of the graph is increasing? And of course they relate theirs to heart rate when they ask the question, but I could say, what is the amount of time in the beginning of the graph where the speed is increasing? Well, you can see over here we're starting at 0 minutes, right? And this line is going up. That means it's going to be a positive rate of increase all the way from 0 to 10. So the amount of time would be 10 seconds according to the label on the x-axis, okay? Now, the next question is going to say, determine the exact rate of change for that increase. This is where you're going to use your slope formula, okay? So the slope formula is M, or slope. We for some reason they use the letter M for slope, and I'm not sure why that is, but that is universally accepted as the letter that represents slope. So slope is y2 minus y1 over x2 minus x1. So what I'd like to do is talk to you about where those x1s and y1s and x2s and y2s come from, because sometimes that's confusing for students. So I'm going to show you that at the beginning of this line down here at point A, and then up here at point B at the end of that line that's showing the increase, we've got points, right? Those are end points of that line segment. So this one I'm going to consider to be, well, the coordinates are 0, 0, right? And the coordinates of this one, it looks like along my x-axis, I would be at 10, and then it goes up to 50. So this one is actually the point 10, comma, 50, okay? So here's the thing. When you're looking at your first point, we can call that first point x1, y1, because every ordered pair consists of an x and a y. So this second one at point B is also an x and a y, but we're going to consider this to be our second point. So we're going to call that x2, y2. So think about the ones and the twos, meaning your first point and your second point. And to be quite honest with you, it doesn't matter which one you choose as your first point and which one you choose as your second point, as long as you're consistent, okay? So as long as the x and the y value are coming from the same point, your x1 and y1 are coming from the same point, it doesn't really matter which one you start with, okay? All right, if you get confused on that, let me know and I can show you an example, but I don't want to spend a lot of time in the video on it. So here we go, my y2 value. Now that I have things labeled, you can see that my y2 value is 50 minus my y1 value, that's the y value from my first point, is 0 over x2. The x2 value from my second point is 10 minus x1, and the x1 value from my first point is 0. Okay, so you do your subtraction. 50 minus 0 is 50. 10 minus 0 is 10. 50 divided by 10 is 5, okay? So now a big thing I like to try to point out is 5 what, right? So remember, we're talking about a rate of change. And whenever we're measuring on the y-axis, which is what we're doing with the top, right? We're saying basically we had a change of 50 miles per hour in a time span of 10 seconds. We get that from our x-axis because the change along the x-axis was 10 seconds. So this is a change of positive 5 miles per hour per second. Now then, I know that seems a little strange, but I want you to think about this. Imagine that you're in a vehicle going up I-25 with one of your grown-ups, right? So you're in the car and you're driving up I-25 and you just get off of the ramp and you start speeding up to get up to the speed limit, right? So you're going to say that every second, according to this graph, the speed of the car, which is measured in miles per hour, is increasing by an additional 5 miles per hour. All right. So that's kind of what we're talking about. Basically, the car is accelerating through this time period. Okay. Now, moving on. Now we're going to take a look. I'm actually going to erase I'm going to erase my label here. And here, because of course that x1 and y1 and x2 and y2, you get to assign that for whatever you need at any individual point in time, right? So I'm going to go to the next chunk of my graph, which is this horizontal line right here, and I'm going to get my ordered pair for point C, and there's actually an easier way to do it than the ordered pair. I'm going to show you the ordered pair way first, and then we're just going to talk about what that means. So my ordered pair here on my x-axis, I'm going over to 25. And then my y-axis, I am still at 50, okay? Now, I always consider the point that's more to the right, I consider that my second point. So I'm going to say, here's my starting point. This is now what I'm going to call my x1, y1. Remember, I get to decide. I get to decide if this is my x1, y1 or my x2, y2. I get to make that choice, just like you would get to make that choice. Okay, and I always make the one further to the right my x2, y2. So this is going to be my point x2, y2. That's point C now. Okay, so here's what this says. From a time frame of 10 to 25 seconds, right? So that's a time span of 15 seconds. What's happening to my speed? It started off here at 50 and it is remaining at 50. Okay, so we're going to call this, I'm just going to call this part 1. That first slope that I calculated was part 1. I'm going to call this part 2 of my graph. Now I'm going to calculate the slope for part 2. So I'm going to show you how to do this with the formula first. y2 minus y1 over x2 minus x1. My y2 is 50 minus my x1, minus my y1, pardon me, my y1 is also 50 over my x2 value is 25 minus my x1 value is 10. Okay, now 50 minus 50, you guys have known how to do that for a long time. 50 minus 50 is 0, all right? 25 minus 10, of course, is 15. And you're going to see that down here, we already talked about a lapse of time between the 10 and the 25. We said that was a 15-second span of time. Well, that's what this represents. I'm really just getting the difference in the time frame according to the x-axis. Now, this represents what was my increase in speed. Well, guys, you can see that here because it's a horizontal line. It doesn't go up. There is a visual component to this. It doesn't go up, it's horizontal, it stays the same. So this actually turns into a 0 mile per hour change, and that's per second, as you're driving along the highway. So the car is at a consistent speed, right? According to the graph, we're driving along at 50 miles per hour, and we're going to keep it at 50 miles per hour for that 15 seconds, okay? All right, moving right along. Let's go on to the third component of the graph, which is what I just labeled on the screen. Okay, again, I am going to erase my x1, y1 and my x2, y2 because I get to choose where I do that for every individual situation that I have to calculate, okay? So point D is what I'm going to be looking at now. Point D, my x value is at 30. Whoops. And my y value is at 20. Okay, so now if I'm going to calculate the rate of change from C to D, now I'm gonna call this one my x1, y1 at point C, and point D I'm going to call that my x2, y2. All right, so now we're going to fill in the formula. Well, I'm writing out the formula. I actually want to talk to you about this line first, though. So from point C to point D, notice that my line this time is going down as it goes to the right. So what that means is my speed overall is going to be decreasing over this amount of time. So what does that mean when you're driving in the car? That means the person that's driving is putting on the brakes. They are slowing down. So maybe they're coming up to a stoplight. Maybe they see cars ahead of them with brake lights on, so they're slowing down for the cars with the brake lights. You know, any kind of situation could happen, but the point is this person, for whatever reason, is having to slow down the vehicle. Okay, so now let's apply the formula and see what we get. My y2 value is 20 minus my y1 value is 50 over my x2 value is 30 minus my x1 value is 25. Okay, when I subtract here, 20 minus 50, now this time I have more negatives, right? So I'm going to end up with a negative 30 over 30 minus 25 is 5. This works out to be 30 divided by 5 is 6, and this happens to be a negative value. So negative 6 miles per hour per second for that 5 seconds. So that means for 5 seconds in a row, the car is decreasing. That's what the negative sign means, is it is decreasing its speed by 6 miles per hour for each second during that time frame. Okay? All right, so I have already taken almost 15 minutes of your time, but thank you for staying with me and watching the video. Notice I did not calculate from D to E or E to F, but if you would like to pause the video and make those calculations, maybe I will pause my video, but then I will start it up again and put those calculations down at the bottom. So I would suggest then that you pause the video now, and then when you play it again, you'll pop up the next 2 chunks of the graph, and I'll put those values up there if you'd like to practice and calculate that slope. Okay, if you still have questions, please feel free to contact me. I hope you're all doing well. Thanks. Bye. All right, welcome back, guys. I hope you took a few minutes and you tried to calculate the slope of the line DE, or from section 4 on our graph, and then hopefully from E to F as well, or section 5 on the graph. If you did, 0.67 miles per hour per second is what I got for section 4, or from point D to point E. So that's going to be an increase of speed of 0.67 miles per hour per second. So a relatively slow increase in speed for that 15-second time span. And then from E to F, you can see from E to F, the car comes all the way to a stop. That's going to be negative 6 miles per hour per second. Again, you can see because the graph is dropping as it goes to the right. That happened from C to D as well. That is going to be a negative rate of change, or a decrease. All right. So again, the other thing I want to point out, in section 5, I got negative 6 miles per hour per second. And in section 3, we also got negative 6 miles per hour per second. So the rate of decrease is the same there. Okay, and what I want to point out is visually on the graph, you can see that those 2 lines, they look like they have about the same steepness as they're dropping to the right. And as it turns out, because we just calculated the numbers, they actually have exactly the same steepness. Okay, so those lines technically would be parallel, and because they have the same slope, and you're going to learn a little bit more about that when we get to systems of equations later on. But you might want to keep that in mind, because that's going to be a consistency you're going to hear about. Okay, guys, like I said, if you still have any questions, please feel free to touch base with me and let me know. And I hope you're all doing well. Thanks. Bye.